Dear 10th class students, today's topic is from pair of linear equations. You know that linear equation means representing a line on the graph. Linear equation represents a line on the graph. Pair means two. That means two lines are here. Now the question is how two lines exist on a plane. Did you understand the question? Two lines are there. They are on a plane. In how many cases they exist? Yeah, first case. They are intersecting lines and they are parallel lines. And third one, they are coincident lines. That means the second line falls on the first line. That is coincident lines. When they are intersecting lines, this is intersecting lines. This is intersecting lines. The intersecting point is the solution. The intersecting point is the solution of the pair of linear equations. It is only one point. So the solution is exactly 1. That means it is unique solution. Now they are come to the coincident lines. Because they are coincident, every point on this line is a solution. So it has infinite solutions. Now come to parallel lines. Here there is no any common point. So it has no solution. The first two cases have solution. So these are called consistent equations. And third case has no solution. So it is inconsistent equations. Now in this session we discuss these things in detail. Now our topic is relating to consistency in the chapter pair of linear equations. We know that the general form of linear equation with two variables is ax plus by plus c is equal to 0. The condition is mod a plus mod b not equals to 0. This means both a and b should not be 0 at the same time. If both a and b are 0 at the same time, then the equation becomes c is equal to 0. This is not linear equation. So the condition is mod a plus mod b not equals to 0. Now we know that the linear equation represents a line on graph. Let the pair of linear equation with two variables a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Now these lines are intersecting. That means they have unique solution. Unique solution, when they have solution, then it is called consistent. The condition for intersecting or having unique solution is a1 by a2 not equals to b1 by b2. This is very important. Once again I am repeating. Here two linear equations are given to you. First one is a1x plus b1y plus c1 is equal to 0. Second one is a2x plus b2y plus c2 is equal to 0. If a1 by a2 is not equals to b1 by b2, then the lines are intersecting and they have unique solution, and the equations are said to be consistent. Now come to the second case. Lines are coincident. When lines are coincident, then they have infinite solutions. The equations are said to be consistent because they have solutions. The condition for infinite solution or coincident is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Now lines are parallel. That means they have no solution. So the equations are said to be inconsistent. The condition for it is a1 by a2 is equal to b1 by b2 not equals to c1 by c2. The conditions are very important here. Once again I am repeating. First condition, a1 by a2 not equals to b1 by b2. That means they have unique solution and it represents intersecting lines. And a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That means it represents coincident lines and it has infinite solutions. And the third condition, a1 by a2 is equal to b1 by b2 but not equals to c1 by c2. Then lines are parallel and they have no solution, so the equations are said to be inconsistent. Let us come to the questions. Determine whether the following system of linear equations is consistent or inconsistent. Here, the first equation is given as 3x plus 2y is equal to 11 and 2x plus 3y is equal to 4. Now, the given equations should be converted into ax plus by plus c is equal to 0. So, it is represented as 3x plus 2y minus 11 is equal to 0. When we compare it with a1x plus b1y plus c1 is equal to 0, a1 is coefficient of x, that is 3, and b1 coefficient of y, that is 2, and c1 is a constant term, that is minus 12. And now the second equation, 2x plus 3y is equal to 4. It can be written as 2x plus 3y minus 4 is equal to 0. Let us compare it with a2x plus b2y plus c2 is equal to 0. Then we obtain a2 is equal to 2, b2 is equal to 3 and c2 is equal to minus 4. Now find a1 by a2. a1 by a2 is 3 by 2 because a1 is 3 here, a1 is 3 and a2 is 2. So a1 by a2 is 3 by 2. Similarly, b1 by b2 is 2 by 3 and c1 by c2 is 11 by 4. That implies a1 by a2 is not equals to b1 by b2. Therefore, the linear equations are consistent, have unique solution from the above table. Now, another question. Determine whether the following system of linear equations is consistent or inconsistent. The first linear equation is 3x plus 4y is equal to 30. Now we change it into ax plus by plus c is equal to 0 form. So it is 3x plus 4y minus 30 is equal to 0. By comparison, a1 is equal to 3, the x coefficient, and b1 is equal to 4, the y coefficient. c1 is equal to minus 30, the constant. Similarly, the second equation, 6x plus 8y minus 60 is equal to minus 60, becomes 6x plus 8y plus 60 is equal to 0. Now here a2 is 6, b2 is 8 and c2 is 60. Now a1 by a2. a1 is 3 and a2 is 6. So a1 by a2 is 3 by 6. By simplification we get 1 by 2. Similarly, b1 by b2 is also 1 by 2. c1 by c2 is also 1 by 2. Sorry, c1 by c2. c1 is minus 30 and c2 is 60. So minus 30 by 60 is minus half. These are a1 by a2 is half, b1 by b2 is half, c1 by c2 is minus half. So a1 by a2 is equal to b1 by b2, not equals to c1 by c2. Therefore, linear equations are inconsistent and lines represent parallel lines. Now let us go for another question. Determine the number of solutions to the following system of linear equations. The linear equations are given as 4x minus 7y is equal to 5. That implies 4x minus 7y minus 5 is equal to 0. By comparison, with a1x plus b1y plus c1 is equal to 0, we get a1 is equal to 4, b1 is equal to minus 7, c1 is equal to minus 5. Now, the second equation is 8x minus 14y is equal to 10. It becomes 8x minus 14y minus 10 is equal to 0. Now, a2 is 8, b2 is minus 14, c2 is minus 10. Now, a1 by a2 is 4 by 8. So, it is 1 by 2. b1 by b2 is minus 7 by minus 14. So, it is 1 by 2. c1 by c2 is also 1 by 2. So, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Therefore, the linear equation represents coincident lines. So, they have infinitely many solutions. Thank you for listening. If you have any doubts, please call me.